So today we're going to go over lesson 10.1 and 10.2 over areas of different polygons. So let's start out pretty easy with a parallelogram. The formula is just base times height. So here's what you need to know. The base times height always form a right angle. So it forms a 90-degree angle. So if you look at some of these examples that I have here for you, the base and the height, notice, come together and form a 90-degree angle. Now, sometimes when it's a slanted figure, the height is shown to you inside the figure. On the next one, notice how it's not inside the figure. It's just how tall it is. Height, you know what height is. And base is what it's sitting on. So, base times height. And a very tricky one would be over here, base, and this is your height. And again, you're looking for that little box, that 90-degree angle symbol. So on next one, let's just call it A. We're looking for the two pieces that come together to form the right angle. So there's extra information within the picture. So you have to avoid the distractors. So here's my 90-degree angle. So the two pieces that make the 90-degree angle are the 4 and the 5. So the formula we said was base times height. So it's 4 times 5, which is 20 inches squared. Now the unit will always be units squared when we're dealing with area. When you do volume, that's when you have units to the third power. Okay, let's do the next one. Let's call it B. We're looking for the two pieces that make the right angle. Well, the right angle's way out here. So you don't have to find this. A lot of people are concerned and they think they need to find all of this, this space out here, and you don't. You need to know, like, the space, the screen part, which is a 2, and how tall it is, which is 3.5. So again, base times height. Guys, I get in the habit, I write the formula every time. It makes you memorize the formulas, and we will learn lots and lots of formulas this chapter. So 2 times 3.5 is 7 centimeters squared, and you're finished with that one. Let's do the next. Let's call it C. There's only two numbers here. So we're looking for the two pieces that make the right angle, which would have to be the 14 and the 8. So base times height. 14 times 8. Let's get the calculator. I believe that's 112. Now, if the unit's not shown to you, you normally put a U for the word unit, and then you would square it since it's area. Now we're going to go through some of these pretty fast. So, I give my class an index card normally, and I have everyone write down the name of the shape, the name of the polygon, and then the formula. So you have a quick reference card for the entire chapter. So for a triangle, it's 1/2 base times height. So it's the same formula as before, but we're going to also times it by 1/2. Now, a formula tweak that I like to do is base times height and divide it by 2, which is the same thing as timesing by 0.5. So, it's up to you. I like it. It seems to be easier. So on the next one, my base, you guys know what base is. The height is how tall is the triangle. And we're going to multiply those and then divide by 2. Now, the reason we're dividing by 2 is because really this is half of a shape that we had up above. So let me show you what I mean. If I were to draw this in, you can see that it was a 4-sided figure, but now it's half of that figure, so that's why the formula says half. And this next example kind of shows you that. They drew in this other side here to show you that it used to be, or it could be, a 4-sided shape, and now it's a 3-sided shape. So the base and height, the base is the bottom, the height is how tall it is. Let's try a real problem. So we're on example 2, part A. So there's lots, oh, this is a hard one to start with, guys. All right, so we need to find this base. We need to find the right angle, this piece here, which, guys, we don't know either of them. So we're going to have to do a lot of work. Like I said, this is a tough one to start. So to find this side, let's call it X, I'm going to have to do Pythagorean. We know this is a 90-degree angle here. So I can take my hypotenuse and square it and make it equal to 6 squared plus x squared. So 100 equals 36 plus x squared. I'm going to subtract 36 to get 64 and square root both sides. So x is 8. All right, so I'm going to erase where I have the x and say that it is 8. Okay, so we're moving, we're going places, but we're still missing this piece because I need to know how big this entire base is. This is my base, but I'm missing part of it. So I need to do Pythagorean one more time to find, let's call it y, to find y. So I'm going to take 17 squared and set it equal to 8 squared plus x squared. All right, so let's grab a calculator. 17 squared is 289. And so I'm going to subtract 64 to the other side. And I get 225 equals x squared. So I'm going to have to square root both sides. All right, so, and again, I'm using a calculator to get these answers. I get 15. Okay, guys, so, we're just trying to do this problem that's pretty easy, but they're making it difficult for us. So I'm using the formula, base times height over 2. Do we have the base and height now? So my base is 15 plus 6. 15 plus 6 is 21. My height is 8, and it's all over 2. All right, so 21 times 8 is 168. Divided by 2 is 84. There's not a unit shown, so I'm going to put a U and then the square. Ooh, that one was hard. This next one's so much easier. We should have started with this one. Oh my goodness. All right, so for part B, we need the two pieces that make the right angle. So there's the 7 and there's the 10. There's the right angle. So question, do we need to know this blue part? And the answer is no, we don't. We just need to know the base. The base starts and ends over here, guys. It doesn't involve that little dotted area. So we don't need to know it. So again, I always write my formula. Base times height over 2. So 6 times 7 over 2. So 6 times 7, of course, is 42. Divided by 2 is 21. And I'm going to put u squared again because the units were not provided. Okay, so next up we have a weird shape. Now, we have a couple choices. We need to break it into shapes that we know. We only know parallelograms so far. We know triangles. So that means we're going to have to find a triangle and find a parallelogram. So you could either continue it up like this and work it out, or take this side and go down. That's supposed to be straight. And honestly, I think that's the better deal because we have a rectangle here, which is pretty easy to do. And then we can figure out this height of this triangle. And yeah, we can do this. All right, so let's do the rectangle. All right, so the formula for the rectangle is base times height. And we have those numbers right away. Here's my right angle, so I have 5 times 16. So 5 times 16, 5 times 16 is 80. Okay, so now we have to worry about this triangle. So my formula is base times height over 2. All right, so let's figure out this base and height. So if this top appears 5, I think you agree, we know from our last chapter, opposite sides of parallelograms are equal. So if this is 5, can we determine the leftover? Sure. So what's 14 minus 5? And that is 9. Okay, so now we need to figure out this height here, because we know this is a right angle. What is the blue part? Well, we know this part up here is 6.5. So what are we going to subtract the 6.5 from? So look at your picture. Do we know the full length? And we do. This side is the full length, and it's 16. So let's take 16 minus 6.5, and you get 9.5, which means it's that length there. Okay, so what are the base and height now? We have 9 times 9.5, and we're going to divide it by 2. So 9 times 9.5 divided by 2 is 42.75. Okay, now to get your final answer, we're going to have to add these two together. And when I add them together, I get 122.75. My unit is meters, so it's meters squared. All right, so when you're finding the area of irregular figures, you're going to find the area of each shape individually and then add them together at the end. Okay, so when you look at this one, you have two choices. You could either find the area of this triangle and find the area of this triangle and add them together. An alternate way would be find the area of this entire figure and then subtract away this part here in the middle. So both would work. Both would work just fine. I'm actually thinking about doing the second way. I think that might be an interesting way to do it. Okay, so if I do the big shape, the one that I outlined in red, that would be a square. And I know it doesn't look like a square, guys, but it's a parallelogram. Opposite sides are equal. Well, here, 14, 14, so it's 14's all around. Okay, so go away. Things pop up on my screen. I don't know how to make them go away. So let's do the square. So it's base times height, 14 times 14. So let's use your calculator. 14 times 14 is 196. Now we are going to subtract away this green part this time. Like I said, I could have done it a different way, but I chose not to. So I'm just going to call it the green triangle. Now I need the base and the height. So I'm going to erase some stuff on here so I can see this better. So this would be my base along the top. Okay, this is my base. And we know my base is 14. So this is the number we need. This is the height. Do we know the height? And I think we do, don't we? Isn't the height here? Get a highlighter out. Isn't this height here the same as this side here? So they're both 14. That's interesting. Okay, so my base and height again is 14. And you know what I did bad? My hand keeps hitting everything tonight. I didn't write the formulas before. So my formula is base times height, but now I'm dividing by 2. So it's 14 times 14 all over 2. So 14 times 14, we already know is 196. Divided by 2 is 98. So remember, we're subtracting this green triangle away. So I'm going to take 196 minus 98 to get 98 feet squared. All right, so we're done with that one. Let's see what else we have. Trapezoid. Okay, write this down on your card. You need to know trapezoids. Now, H, we already know what H is. H is your height, right? And the B is your base. But if you remember from the last chapter, trapezoids have 2 bases. The bases are those parallel sides. So let's look at the picture here. The bases are these 2 parallel sides, and the height is the number that's in between. And notice, it still makes that right angle every single time. Okay, so here's a tweak what I do to this formula. Again, I don't like to times by a half. You can, but I like taking the height times the sum of the bases and then dividing by 2. If you don't like that and you want to do the original, then you can use that formula. That's just how I always do it. Okay, now this is a trapezoid. So my 2 parallel sides, I'll outline it here. Those are the parallel sides. And that means this is my height. So let's write down the formula. Height times base 1 plus base 2 all over 2. So what is my height? My height is 309. My bases are 205 and 511. And then it's all over 2. So thank goodness for calculators. Let's add everything in the parentheses first. So 205 and 511. Then times it by 309. We have a huge number. And then divide it by 2. And it's still a very large number. I get 110,622 miles squared. All right. Let's do an easier one for sure. And it's kind of blurry too. So the bases obviously are these 2 sides. This is your height. Let's plug it in. All right, so area is height times base 1 plus base 2 all over 2. So my height is 14. And then my bases are 9 and 17. And it's all over 2. So with your calculators, you're able to type this totally in with the numerator denominator button if you choose to do that. All right, I get 182. I might try that again just to make sure that's right. And it is 182. There's not a unit listed, so just put a u squared. All right, next one. Again, much easier than that first one. We have our parallel bases. We have the distance between the bases, which is your height. So let's try this again. All right, so I'm writing my formula. Guys, if you do this every time, you will memorize them. So base 1 is 8. Base 2 is 14. It's all over 2. So 8 plus 14 is 22. Times it by 4. And then divide it by 2. and I get 44 units squared. Okay, now we're back to a difficult one. Okay, so here's why it's difficult. They gave you the bases. Bases are the two parallel sides here, but they don't give you the height. The height is normally about right here, which would be the same as RQ, but if you notice, they don't give you RQ. So it's really tricky what they're doing to us. I'll help you through it. If I draw this in, and that makes a right angle, I have a 30, 60, 90 triangle. So we have a trick for the 30, 60, 90 triangle. Do you guys remember this trick at all? So if this is 60 and this is 30, this is my base. To go from the base to the long leg, I times it by √3. So what we need to figure out is, what is this little short length here? And we can figure it out because this top up here is 5 and the entire bottom is 7. So if I subtract them, I get 2. So how do I go from the 2 to this side right here? I take it and I times it by √2. So it's 2 √3. All right, I know that's tricky because it's been a long time. So, as usual, I'm writing my formula down so it's easy to plug it in. My height is 2 √3. My bases are 5 and 7, and I divide by 2. All right, now, I don't have a yellow calculator on me. The calculator I'm using is not that type of calculator. So mine's going to end up in root form. So I'm just going to leave it with the square root in it. It'll be fine. 5 plus 7 is 12. So I'm just going to multiply all the numbers together that are not square roots. So this 2 right here times 12 is 24. So 24 √3 over 2. And then the 2 goes into 24 12 times. So my answer is 12 √3. And the unit is meters squared. Okay, so if you had a yellow calculator, you could have probably typed that in much faster than what I just did. Okay, get your index cards back out. We're going to put this information in it. Kites in rhombi. And it's also correct if you want to say rhombuses. Even though it doesn't really sound right, it's okay. Just the word rhombi and rhombuses both are just a plural form of the word rhombus. Now, we're working with D's now. D's are diagonals. Okay, so let's look at these pictures. The diagonals make like the X inside the shape. They go to the opposite angle. And you need the entire length of the diagonal. And you're going to multiply them together. And then times it by a half. And as you guys probably know, I don't like to times by a half. So you can probably predict what I like to do. I like to take it and divide it by 2. Okay, so let's try this. Let's call that diagonal 1. Do I know this length? Sure. Let's just add it together. 2 plus 5 is 7. What is the length of the diagonal going the other way? 3 plus 3 is 6. So my area is, now what's my formula? D1 times D2 over 2. So 7 times 6 over 2. Okay, 7 times 6 is 42. Divided by 2 is 21 meters squared. Okay, so next one is tricky because if you look at it, it doesn't give you enough information. You have to know things from the last chapter. So on a rhombus, remember diagonals bisect. That's one of those rules that I made you learn. Okay, so if this side appears 3, that means this piece down here is also 3. And this longer side's 5, so that means this other piece down here is also 5. So can you determine the length of the two diagonals? Sure, 3 and 3 is 6, and 5 and 5 is 10. So let's write out the formula. D1 times D2 over 2. So 6 times 10 over 2. So 6 times 10 is 60. Half of 60 is 30. And it's feet squared. Oh, another difficult one. Okay, so on a kite, we know that the diagonals make a right angle. So if one angle here is 45, that means the other angle is 45. And we also know those two sides are the same. And we also know that side is the same. All right, so how do we go on a 45, 45, 90 triangle from the hypotenuse back to the leg? So if this is 9 root 2 and this is 45, how do I go here? So do you remember that you either multiply by root 2 or you divide by root 2? So we're going to a smaller side, so we actually are going to divide by root 2. So 9 root 2 divided by root 2 is 9. And we know the two legs are equal. So this side's 9 and this side's 9. And that side's 9. Yeah, this is a hard one. This really is a tricky one. So what's the lengths of our two diagonals? Going from left to right, 9 plus 9 is 18. Going up and down, 9 and 6 is 15. So to find the area, I'm going to take D1 times D2 and divide it by 2. So 18 times 15 over 2. Grab your calculators. And I get 135 meters squared. All right, next one's much easier. We know the diagonals bisect. So we have two pieces that are 4, two pieces that are 7. So one diagonal is 4 and 4, which is 8. The other diagonal is 7 and 7, which is 14. So D1 times D2 over 2. So 8 times 14 over 2. 8 times 14 divided by 2 is 56 units squared. I think that might be it. It is. All right, guys, so we are finished. So on your index card, you should have 1, 2, 3, 4 equations already. So hang on to these index cards for the entire chapter, and we will add to it daily. Thanks. Bye.